This is the beginning of Chapter 2, and it is also the beginning of our study of something called a function. Now, by definition, a function is a relation, and in our case it will be a relation between x and y, in which each x corresponds to only one y, and that's the critical part right there. An x can have a relationship with one and only one y. We'll see how that is explained in examples in a minute. The domain, and we have studied domain in previous lessons, it is the set of x values, and that's implied that it's the set of x values for which the relationship is defined. The range is the set of y values, and the y got chopped off a little bit there, but it is the set of y values. So let's take this definition of a function and the definition of domain and range and answer a few questions. Number one, this is a relationship. It is a set of ordered pairs, and there are x's in a relationship with y's. Determine whether this relation is a function. It is a function if 3 has a relationship with 4, and I never see 3 having a relationship with any other y value. 5 is with 5, no other y value. 7 is with 7. If in a minute we'll see something that's not a function, and you will see that this correspondence between x and y is not unique. So is this a function? The answer is yes. For each x there is only one y. What is the domain? It is a set, and it is the x values. It is 3, 5, and 7, the x values. What is the range? It is the set 4, 5, and 7. All right, so domain is the set of x's for which the function is defined. Range is the set of y's. Number 2, is this a function? Well, 7 has a relationship with 9. 7 also has a relationship with 10. 7 has a relationship with 11. So this is definitely not a function. The definition of a function says each x can correspond to one and only one y. And this 7 has a bunch of different y's. So the domain, all I will list is 7. Even though it's up here 3 times, in a set you only list a unique element once. The range is 9, 10, and 11. All right, moving on. When determining if an equation, not a set of ordered pairs like we were looking at, but when you're determining if an equation is a function, we're going to look at it for polynomial functions only right now. If the exponent of y is even, then it's not a function. If the exponent of y is odd, it is a function. So, because we're always saying, is y a function of x? If y is even and you tried to solve for y, you would have to use a plus or minus, and that would mean that there were different x's, that an x would correspond to more than one y. All right, so remember, we're going to check y. If the power is even, then not a function. Look at y. If the power is odd, it is a function. All right, so in this one, we look at the power of y. The exponent is a 1. That means that yes, this is a function. That comes from if you were to solve this equation for y, you would say y is equal to 16 minus x squared. If you put in a value for x, square it, subtract it from 16, you will get one and only one y. I'll show you the counterexample in just a minute. Well, maybe I will if there's one. In this one, is this equation, is y a function of x? We'll look at y. Oh, its power is odd again. And when it's odd, it is a function. So let me go ahead and give you just a counterexample. If you had x squared plus y squared equals 4, which by the way happens to be the equation of a circle, and you got y by itself, you'd have y squared is equal to 4 minus x squared. When you use the square root property, which we've studied before, you'd get y is equal to plus or minus the square roots of 4 minus x squared. If you did that and you picked a value for x, plugged it in, squared it, subtracted from 4, you would get two different answers. That means that if, and I'm going to make one up, if x is 0, 0 squared is 0, subtracted from 4 is 4, plus or minus square roots of 4, you get plus or minus 2. And this means that you have the point 0, 2 and the point 0, negative 2. X does not have a unique y. So this example is not a function. And it has to do with this even exponent of y. All right, now, if a relationship y equals, for instance, 3x plus 7, if the relationship satisfies the definition of being a function, and this is a function, then the y can change its name to reflect that it is a function. F of x would be its name, and that's 3x plus 7. So in a function world, if the y is a function of x, then we change its name to f of x. Now that's not unique. We could call it g of x, 3x plus 7. We could call it h of x, 3x plus 7. These are the typical function names, but certainly other letters could be used. So think of this as nothing more than a name change. F of x is a new name for y, and by using this new name, I don't have to study this equation and say, I wonder if that's a function. I don't have to, because you could not call it a function notation name unless it were a function. All right, so now that we've talked about function notation, number 5 says, suppose we have f of x is 6x plus 5. Now, this is, in our old notation, y equals 6x plus 5. But because it's a function, they've changed the name. This particular problem says, well, evaluate it. So we're going to explore a little bit of function notation. All right, so I have f of x is 6x plus 5. F of negative 5 is, well, if they put negative 5 in the place of x, then I will too. 6 times negative 5 plus 5, which is negative 30, plus 5, which is negative 25. So my first answer is negative 25. It's kind of messy. Next, they said, all right, so now find f of x plus 7. Now I know this looks a little odd, but in the definition, where there used to be an x, I'm going to put an x plus 7. So it will be 6 parentheses x plus 7 plus 5. Do you see that in the place of x, I have put the expression x plus 7, and I did it because the function name told me to. So to simplify this, 6 times x is 6x, 6 times 7 is 42, plus 5. Combining like terms, I have 6x plus 47. So f of x plus 7 is this new expression. So I will put 6x plus 47. So this was A, and this is B. Part C asked me to find f of negative x. That means put negative x in the place of old positive x. So it will be 6 times negative x plus 5. All I'm doing is substituting whatever is in the name position for x in the place of the definition. So that gives me negative 6x plus 5. All right, we'll do more with this, but just remember, in this problem, if it said, what's f of smiley face? I would say, well, it's 6 times smiley face plus 5. Whatever they tell me is in the place of x, I put in the place of x in the definition side of the function. There was nothing I could do with that. It was a silly example, but I thought it might help. All right. Now, with number 6, we're about to notice something called a transformation. This particular problem says, graph the given functions f and g in the same rectangular coordinate plane. So I have a coordinate plane given. In my math lab, I will click the tool that looks like a line. And I'll have to do it twice. All right, the first one, it says to graph f of x is 4x. So I'm going to hopefully remind you of something. Remember that f of x is the same thing as y. So this is y equals 4x. I'd like to think of y equals mx plus b, the slope-intercept form of the equation of a line. In my problem, 4 is in the place of m. There seems to be nothing in the place of b, so I'm going to put a 0, and I'm going to say b is equal to 0, m is equal to 4. M is the slope. The slope is the rise over the run. So I'm going to give it a denominator. I'm supposed to rise 4 and run 1 from any point on the graph to get to another point on the graph. Now my graph is not going to be beautiful because in this electronic environment I can't really use a ruler, but you would click the line tool, then put a point at 0 on the y-axis, that's your y-intercept, and it doesn't want to keep the point, there it is. From there it says to go up 4 blocks, right 1 block. So if I go up 4 blocks and right 1 block, I get a point right there, and I'm going to try to draw a straight line, but there is no real promise that's going to happen. And well, it didn't happen at all. Let me try one more time. Okay, sort of, not great. It also said to graph g of x. So I'm going to switch colors. So g of x is 4x minus 2. So thinking in terms of y equals mx plus b, remember g of x is just a function name in the place of y. This tells me that the b value is negative 2. It's so important that you remember that's always on the y-axis, and the slope in this problem is 4. You need a rise and a run, so I need a numerator and denominator. Up 4, right 1. So this problem, I have a y-intercept, it's so hard to get it to graph, at negative 2. And then if I go up 4 and over 2, this is not really going to come out perfectly, but this is supposed to be, oh, that's really bad. It's supposed to look like this. Oh, it's not supposed to intersect. Let me try that first one again. All right, so 0 and up 4 and over 1. So it looks kind of like this. I'm drawing this freehand, so sorry. In MATLAB it will be a beautiful graph for you. And this one, it's 2, and there's that. So I get this line. So what you're supposed to get, not this ugliness that I just got. All right, I have tried to make it a better looking graph, but it really did not come out very good. In my MATLAB, you will click the line draw tool, and then you will click a point at 0, and then you will move your mouse up 4 and over 1 and click again. Then you will click the line draw tool again. This one's y-intercept is at negative 2. Click, then you will go up 4 and over 1 again. You will get parallel lines. Mine doesn't look like it, but you will get parallel lines. So it says here, how is the graph of G related to the graph of F? The graph of G is shifted 2 units vertically down. Let's see. The y-intercept was 0. This y-intercept is negative 2. This point is 4, 1. This point is, is 1, 4. This one is 1, 2. It did not move to the G did not move to the left. G really did not move to the right. This is it. It was shifted down. Every point on the red graph is exactly 2 units down from the black graph. You can't see it well on mine, but it is a vertical shift of down 2. And you will see later that this means vertical shift down 2. Makes sense, negative 2. All right, let's look at the next one. All right, question number 7. We're still graphing some functions, and we're beginning to learn about some relationships between similar functions. And this one asks us to graph f of x is equal to x squared. And this one asks us to graph g of x is equal to x squared plus 1. Rather than try to draw it here, I wanted to show you what it would look like in my MATLAB. So I've got the same question in my MATLAB, and I'm going to ask it to enlarge this. All right. Last time we graphed a line. This time we are graphing what's called a parabola. With a parabola, I need 3 points. Okay, So the first point, let me go back because I can't write on this. I'm so sorry. All right, so let's go ahead and get for f of x equals x squared. We're going to need 3 points. So instead of calling it x and y, we'll call it x and f of x. If x is 0, then 0 squared is equal to 0, and that's your y. If x is 1, f of 1 is 1 squared, which is 1. And if x is 2, f of 2 is equal to 2 squared, which is 4. So I will do 0, 0, 1, 1, and 2, 4. All right, I need 0, 0, 1, 1, and 2, 4. You could pick any 3 points. All right, so I'll save that one. Now I need to graph g of x is x squared plus 1. So if I go back and I work on, let's scoot this for a little, g of x is x squared plus 1, and I made a t-chart. Then I have if x is 0, 1, and 2, and you can pick anything you want, but I have g of 0 is 0 squared plus 1, which is 1. G of 1 is 1 squared plus 1, which is 1 plus 1, or 2. G of 2 is 2 squared plus 1, which is 4 plus 1, or 5. So 0, 1, 1, 2, 2, 5. Hope I can remember those. So I'm going to enlarge this. Click this tool again. I need 3 points. 0, 1, 1, 2, and 2, 5. Okay. Now it's sort of hard to see, but I hope you can see that the second graph I did was a shift up from the first graph. It shifted up. If I went back to the ordered pairs, I could even see it. Can you see that this y is 0, this y is 1, this y is 1, this y is 2, this y is 4, this y is 5. Each one of the y's, which is a vertical, has been shifted up 1 unit. So if I go back to my MATLAB, it says, what did it do? Well, it shifted up. We saw that. So I pick C. Once again, I check my answer, and it is correct. So now let's go back to our other screen. Here we go. All right, this one's going to be multiple choice, so I don't need to use the graphing tool. It says graph the given function f and g in the same rectangular coordinate plane. And then we're going to see if we can notice something. And they're telling me to use x is 0, 1, 4, and 9. This is a different function. So far, I've looked at linear, which is y equals mx plus b. Its shape is a line, although it can slant the other way. Then I looked at what's called a squaring function, which is y equals x squared. Now I'm going to, and the shape was like this. Now I'm going to look at a square root function, which is y is equal to the square root of x. And I will just tell you that this looks kind of like, my name for it is a branch. All right, so the first thing they want me to do is to get some points to figure out what f of x would look like. Well, all right, I have this chart, but I'm going to do it over here. I have x and f of x. Remember, f of x is just another name for y. They tell me to pick 0, 1, 4, and 9. 0, 1, 4, and 9. F of 0 is the square root of 0, which is 0. F of 1 is the square root of 1, which is 1. F of 4 is the square root of 4, which is 2. And f of 9 is the square root of 9, which is 3. Now, they ask me then to go on and to find g of x. So if I had x and g of x, remember that's just another name for a different y. If x is 0, g of 0 is the square root of 0, but plus of 4, and that will give me 4. If x is 1, g of 1 is the square root of 1 plus 4. Well, the square root of 1 is 1, plus 4 gives me 5. If x is 4, g of 4 is the square root of 4 plus 4. That's 2 plus 4, which is 6. And finally, if x is 9, g of 9 is the square root of 9 plus 4. That's 3 plus 4, which is 7. All right, now it asks me to pick the graph that is correct. Now, rather than try to check for the plotting of those points, let's look here. What's the relationship between these y's? 0 to 4, 0 and 4, 1 and 5, 2 and 6, 3 and 7. Can you see that each of these is up by 4? And that will be in a vertical direction because it's a y. So I'm looking for branches, and the first one will be start at 0, 0, and the second one will be up from that. And it looks like, and by the way, this is 2, 4, 6, 8, 10, 12. So scaled by 2. This is our graph. If you could blow this up bigger, you could actually plot the points and see that there's 0, 0, there's 1, 1, there's 0, 4, there's 1, 5 from this. What happened? It shifted up 4 units. So what you're going to notice is if you have f of x equals any function of x, and then you have g of x equal the same function plus some constant. I'm just going to put letter c. If these are the same and you add a c, it will always shift up c units. All right, so please write this down in your notes, and I'm going to have some more summary in a few minutes. Let's look at our next question. All right, in this one, it says graph the given functions f and g in the same rectangular coordinate plane, but it is going to be a multiple choice question. These are still f of x, which I like to many times call y, is the square root of x. So this is still that branch. All right, they are giving me different x's to plug in. So let's take a look at x and f of x. The first one. They're saying to use 0, 1, 4, and 9. These are the same points we did in the last problem. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. So the first graph is going to look the same. It's going to have a point here and it's going to be a slight branch. But let's look at the second one. We have x and g of x. This time they want me to use 6 and 7 and 10 and 15. So they're asking me to use completely different numbers. So g of 6 will be the square root of, now this is all under the radical, x minus 6, which is the square root of 6 minus 6, which is the square root of 0, or 0. Okay, the next one, it wants g of 7, which is the square root of, I'll just go ahead and put 7 minus 6, which is the square root of 1, which is 1. Next one, g of 10 is the square root of, in the place of x I put 10 minus 6, which is the square root of 4, which is 2. And g of 15, which is the square root of 15 minus 6, which is the square root of 9, which is 3. So I've changed the x's and got the same y's here that I got here. The x's increased. This one, this x increased by 6, this x increased by 6, this x increased by 6, and 9 plus 6 is 15. When you increase x, you move to the right. So I am going to be looking for a graph that shifts right 6 units, but other than that is the same shape. This one looks like one of them turned around. This one looks like it did move a certain number of units, and if you could blow this up, this is counting by 4s. 4, 8, 12, 16, 20, 24. That's a little misleading, but from here to here, although it does, you just think it's 1.5, it's really 6. This is my answer. In my math lab, you can actually see this because you can blow the graph up. And how did it change? It shifted right 6. And I'm going to go ahead and put a summary statement in here right now that you may have seen it in the past and maybe not. All right, so this is what this is called transformations. This is the first time you're seeing this. You're going to see much more of it. If you have y is some function of x, and you have another y which is the same function of x, but they add something to it, it's going to shift up A units. That A might be 5 or 2 or 7, who knows. If you have y is equal to the same function minus a constant, then it will shift down A units, where A represents a number. If instead you have y equals f of x plus a, where you're adding to the a before you're letting the function act on it, you're going to shift left a units. And if you have y equals f of x minus a, you're going to shift right a units. This is in your printed notes as well. When you add and subtract after the function has acted on the value of the domain, after it's acted on the x, like you squared it first and then you added something to it, when this is on the outside, it affects it vertically. But if you change the x before you act on it, as we did up here, we subtracted inside before we took a square root. If you do that, it affects it left, right. So this is horizontal. And something that seems a little odd is that plus is an up direction, minus is a down direction, but when you're talking about the horizontal shifts, it goes in the opposite direction of what that says. So, like I said, this is in some of your notes. This was our first exposure to it. Now we're going to talk about what's called the vertical line test. This is a test for functions based on their graphs. So if you're going to test, is this a function, we have done it with sets of ordered pairs. We had 1, 2, and 3, 5, and 4, 7. And we said, yes, it is a function because each x had one and only one y. We also had y equals x to the third minus 7. Or we might have y squared equals 2x plus 3. From equations, what we said, and this is a limited test, but what we said is look at the exponent of y. If the exponent is odd, then yes, it is a function. If the exponent is even, then no, it's not. Now, we've looked at a relation with ordered pairs and determined if it was a function. We've looked at relations in equation form to determine if they're functions. Now we're going to test a graph. Now let me remind you of the definition of a function. Each x corresponds to only one y. All right. So if I look at a graph and I want to know, is this a function? Let me go to red ink. If I look at a vertical line, hopefully you remember from some time that if you had x equals 2, that is a vertical line that cuts through the x-axis at 2. Every point on that vertical line, the x is 2. The y might be 0, the y might be 1, the y might be 5, the y might be negative 4, but the x is 2. So a vertical line represents an x. So if I look at this x and 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 this x, each one of those x's and all the infinite ones that I didn't draw touch my graph, intersect my graph in only one spot. When that happens, it passes the vertical line test. So it is a function. You'll see a counterexample coming up. Take a look at this. This graph looks like a rectangle. So I want to know if that represents a function. So I start looking at some representative vertical lines. I've only drawn 3. There are an infinite number of them, but this vertical line intersects the graph in 2 places. It is possible, I'm just going to make this up, that this is the point -1, 2. It is possible that this is the point -1, -2. Do you see that this x corresponds to 2 different y values? That's what happens when you fail the vertical line test. So this is not a function. If there is even a single vertical line that intersects your graph more than once, it's not a function. Just as a quick example, if I had asked you if this is a function, you would do a vertical line test and you'd say that's a function. But if I had this graph and I said, is that a function? You would do your vertical line test and you would say, no, not a function. Because a vertical line represents an x. And so if it crosses your graph more than once, then it just violated the definition. All right, let's work a little bit more with function notation. What's important is that you, let me go to black ink. You remember that a point is x comma y, but in function notation it is x comma f of x. You have to remember that f of x is just another name for y. If you have a coordinate plane that you used to call the xy coordinate plane, now you have an x f of x coordinate plane. Do not let it bother you. Just remember that f of x is a new name for y, but it provides extra information. So if I say f of 3 equals 8, then I am talking about x is 3, f of 3 is 8. This represents the point 3, 8. All right, so f of a number, remember, new name for y, but it's telling you what the x was to get that y. So here it says, use the graph f to find the value of f of -1. When it says f of -1, it wants a y value. It's giving you an x value. It's telling you x is -1. So this question could be restated when x is -1, find y. So looking at this, when here's my 0, 0, when x is negative 1, it looks like it's hitting the x-axis, so f of negative 1 is 0. The point is negative 1, comma 0. There's your x. There's your f of x. All right, let's look at the next one. This just takes a little bit of getting used to. When they say g of negative 4 is, they're saying if x is negative 4, find the corresponding function value. So you're going to find the y. So I'm looking at an ordered pair which is negative 4 what? So when I look at the graph, when x is negative 4, where's the point on the graph? It's right here. And it looks like the y value is 6. This is the point negative 4, 6. So g of negative 4, the function when x is negative 4, is equal to 6. Number 14 is stated a little differently. It says, for what value of x is g of x equal to 7? So when they say g of x is equal to 7, that is the y value. So they could say, find x when y is 7. Okay, so when y is 7, I'm up here and I'm looking to see where the graph has a point there, and it's right here. So what is that ordered pair? That is negative 2, comma 7. So what they want to know is what's the x when y was 7, and it was negative 2.